So hello everyone. So now we will discuss about the most important and tough concept in advanced level. Okay, it's nothing but a nature of roots of a cubic polynomial. Nature of roots of the cubic polynomial. So I will explain nature of roots of cubic polynomial. So first of all, define one function, f of x function. It is a cubic polynomial function. So it can be taken as f of x equal to ax cube plus bx square plus cx plus d. F of x is ax cube plus bx square plus cx plus d is the cubic polynomial. Okay, now I am finding the derivative of this function. Why? So why you are finding derivative of this function? Why? Because already we know the nature of roots of the quadratic equation. Okay, so first convert the cubic equation into quadratic equation, and then we can analyze the nature of roots of the cubic by using nature of roots of the quadratic. Okay, so now we can write f dash of x value. What is f dash of x? That is 3ax square plus 2bx plus c. So this is f dash of x and it is a quadratic. Now how to check the nature of roots of the quadratic? By using a discriminant of the function. What is the discriminant of the quadratic? It is nothing but a delta. Delta means b square minus 4ac. Okay, by using delta value we can conclude the nature of roots of the quadratic function. Okay, now so again here we have three possibilities or exist for discriminant. So those are delta equal to, delta is less than 0, or delta is greater than 0, or delta equal to 0. So three possibilities are exist here. By using these three cases, we can conclude the nature of roots of the quadratic equation. From that we can conclude the nature of roots of the cubic equation. Okay, now first of all let us see the case 1. What is case 1? Here case 1 is delta is less than 0. Delta less than 0. Delta less than 0 means the quadratic equation, that means it is nothing but f dash of x. It contains two imaginary roots. It is a quadratic equation. That means f dash of x having two roots. Let it be alpha and beta. Alpha and beta. So this alpha and beta are imaginary. Alpha and beta are imaginary roots. Why? Because the first case is delta is less than 0. In less than 0, f dash of x has imaginary roots. Okay. So by using this one, by using nature of the quadratic, we have to define the nature of the cubic equation. Okay, now so here we can observe that by using the concept of monotonicity, we have two possibilities that exist for f dash of x. That is whether f dash of x is greater than 0 or f dash of x is less than 0. F dash of x greater than 0 or f dash of x less than 0. If it is greater than 0, what is f of x? It is a increasing function. If f dash of x is less than 0, what is f of x? It is a decreasing function. That means given function is increasing or decreasing. Okay, finally what is f of x in this case? Either increasing function, strictly increasing or strictly decreasing. So now let us see the graphs. Either strictly increasing or strictly decreasing means the graph of the function intersect on x-axis at only one point. Okay, so in these two cases, two possibilities that exist here. By observing these two graphs, our conclusion is the graph. This is the f of x graph. This graph is nothing but a f of x graph. Okay, So f of x either increases, strictly increasing or strictly decreasing. In these two cases, the graph must be intersect on only one point on x-axis. So it contains only one real root. It contains only one real root. So real root means where the graph intersect on x-axis at that point is called a real root of the given function. So how many roots are exist here? Only one real root, either this case or this case. So what is our final conclusion? Okay, let us see one more case. One is real root, it's enough. What about remaining two? So remaining two means here either above x-axis or below x-axis. That means like here, for suppose. We can assume that is also presumption. Either above x-axis or below x-axis. Above x-axis or below x-axis means those two roots must be imaginary roots. Those not a real root. So one root can be taken as that is x1. x1 is real root and x2, x3 are imaginary roots. So finally, the given function contains three roots. Out of three roots, one should be real and remaining two is imaginary. Next, what about in this location, let be alpha and beta. In this location, what is f of alpha and what is f of beta? In first case. So here f of alpha and f of beta, these two are above x-axis. Above x-axis means these two is greater than 0. Okay now, these two is greater than 0. So both are positive means product of their values is also positive. That means f of alpha and f of beta is also greater than 0. So alpha and beta are greater than 0. Next, in second case, in second possibility, these two are below x-axis. That means both are negative. So it is also negative and it is also negative. So what is their product? F of alpha into f of beta. It is f of alpha negative and f of beta is also negative. Then again f of alpha into f of beta, it is also greater than 0. That means minus into minus plus. The product of these two cases is also greater than 0. From these two graphs, our final conclusion is if the given function having only one real root, the given function, the given cubic polynomial function having only one real root, then what is condition? F of alpha into f of beta is must be greater than 0. That is the final conclusion. Okay now. Next the case 2. The case 2 is delta is greater than 0. Delta greater than 0. Greater than 0 means a discriminant value positive. Discriminant positive means what is condition? F dash of x, that means quadratic equation contains two real roots. F of x, that means the quadratic equation contains two real roots. In quadratic equation means f dash of x. So f dash of x contains two real roots. Again, let it be alpha and beta by our convenience. Now these two are real roots. These two alpha and beta are real roots. Now, so now we can write f dash of x value 3a times of x minus alpha into x minus beta by the concept of quadratic equation 3a, because what is x square quotient here? 3a. So a times of x minus alpha into x minus, that's a condition. So 3a of x minus alpha into x minus beta. Okay now so this is the condition. Now by using the wavy curve method we have to calculate it. So it is the good way to calculate it. Let us take wavy curve method. So this is minus infinity and this is plus infinity. Okay, so this is alpha and beta. Alpha and beta, those two are real roots. Real root means intersect on x-axis. Here we can observe that. So here f of x is positive. Here the f of x is positive. Okay. So here f dash of x. F dash of x is positive. So in this side f dash of x is positive. So in these two locations f dash of x is a positive. Why? Because minus infinity to here, this is an increasing graph. Here from here to here, it is an increasing graph. In these two cases, it is a f dash of x is greater than 0, positive case. So what about here? So in this location, what is f dash of x? So in this location f dash of x is less than 0. Okay, so finally if f dash of x is greater than 0, f dash of x is greater than 0, what is x? X belongs to minus infinity to alpha union beta to infinity. This is the interval, minus infinity to alpha, beta to infinity. In these two intervals, f dash of x is greater than 0. Next, what about this location? In this location, f dash of x is less than 0. Less than 0 means what is the interval? That is open interval alpha comma beta. Open interval alpha comma beta. So f dash of x is less than 0 means x belongs to open interval alpha comma beta. F dash of x greater than 0 means x belongs to minus infinity to alpha union beta to infinity. Okay. So again here we can observe that here we have two subcases. So what are the subcases? That is, actually here we define alpha and beta real roots. So real roots means again two possibilities, either real and different. Okay, real and or distant or different. And next one is real and equal. Again we have two subcases. Now let us see that subcases. Now I am going with the first subcase. Subcase 1. So what is subcase 1? So here we will take three roots are real and distinct. Three roots are real and distant. So three roots are real and distant means the graph of the given function intersect on x-axis at three different places. At three different places or different positions. Now let us see the graph. The graph like this one. Okay. So what is this one? This is alpha and beta here. Alpha and beta. Alpha. Next. Here we can observe that from here to here the graph is increased. The graph is increased. That means f dash of x is greater than 0 in this location. So after that what happened? That means from here to here the graph will be decreased. Graph will be decreased means so what is derivative? It must be less than 0. Okay. Decreasing graph means derivative less than 0. Increasing graph means derivative is more than 0. Next again after beta. So after beta what is graph? What is the position this graph? It's like increasing. Increasing means again f dash of x is greater than 0. Okay now. Next let us see. Here we can observe that. So this is alpha. What is this point? It is nothing but a f of alpha. And what about this point? It is nothing but a f of beta. Okay. This is f of alpha. So f of beta. That means at f of alpha. So after f of alpha the graph will be decreased. After f of beta the graph will be increased. Okay. Here we can observe that by the drawing the graph of this one we can analyze f of alpha is greater than 0 and f of beta is less than 0. That is our conclusion. F of alpha is greater than 0 and f of beta is less than 0. In the same way, if here a is negative, this all cases at a is positive. If it a is negative, we will take reciprocals of this location. Okay, just we will take image of this one. Now it will become to above x-axis, it will become to below x-axis. Okay, so no problem. There is no changes in conditions. Why? Because if you take reciprocals of this graph, these locations, so what happened? So again, one will be positive and one will be negative. It's compulsory. Okay. So either f of alpha is positive, but in this case, f of alpha positive, f of beta negative. In reciprocal, f of beta positive, f of alpha negative. Okay. So f of alpha positive, f of beta negative. What about the product of these two? That means f of alpha into f of beta. It must be less than 0. It must be less than 0. Plus into minus, minus. Okay, so this is the second condition. So from this condition, what you conclude? The conclusion is f of x has three real and distant roots. F of x has 3 real and distant roots. Then what is condition? F of alpha into f of beta is less than 0. Here what is alpha and beta? Alpha and beta are roots of quadratic equation. Quadratic equation means the roots of f dash of x. Okay, in any question if they ask, so the given function having real and distant root, then find the condition for a or condition for k, like that. So first of all, we can calculate derivative of the function. Find out alpha and beta values. Later substitute these two values in f of x, and we have to multiply these two, take less than 0. By using this condition, we can calculate range of the given constant like a, k, like that only. Mostly they will ask these type of questions in passage, okay, in your advanced examinations. So this is the condition. And the next one is so next case, so real and equal. The next case is real and equal. So real and equal means the condition f of alpha into f of beta equal to 0. F of alpha into f of beta equal to 0. So product of two values equal to 0 means 1 must be 0. 1 must be 0. And the condition is already explained in first case. The condition is always the graph is decreasing to alpha to beta. The graph is decreasing from alpha to beta. That is the condition. Okay, let us see. First, suppose out of these two, which one is 0, alpha or beta? Let us see graph. If alpha is increasing and then alpha is above x-axis, then graph will be like this. If alpha is above x-axis, the beta is touches the x-axis. Okay, the beta value is the curve. That means beta value means curve touches x-axis at beta. If any curve touches x-axis at some point, means it is repeated, and at this value the function will be 0. The function value will be touches means the function will be 0. Okay, then f of alpha into f of beta equal to 0. Next, again it is also depends on the sign of a. If a is greater than 0, then beta will be 0. If a is less than 0, alpha will be 0. That means we will take a reciprocal of this one now. Okay, so this is the second sub case in d greater than 0. So next one is d equal to 0. Next case 3. So now only I explained that one. D equal to 0 means discriminant value 0 means so what is the roots? Real and equal roots. So real and equal roots means so it will become to f dash of x will become to some x minus alpha whole square. That means these two roots are same, x minus alpha into x minus alpha. They are equal to 0. F of alpha and f of beta equal to 0 means the constant term it will be 0. No need to take this value. Actually it is not equal to 0. Okay, 3a value is always not equal to 0. If it is 0, it is not a cubic equation. Okay, that is second thing. Now let's see. F dash of x is equal to x minus alpha whole square. Now apply integration on both sides. So if you apply integration on both sides, integral of f dash of x will become to f of x. F of x. And what about this one? So 2 times of x minus alpha whole cube by 3 some constant, let it be k. Okay, some constant. Next, how to define the roots of this equation? It depends on k. It depends on by the value of k we conclude the roots of this function. That means if it is if k equal to 0, then f of x has 3 real and equal roots. If k is not equal to 0, then only one root is real. Only one root is real. Okay, so sorry, it is not true. Exponent plus 1 by n plus 1 formula. So this is the third one, that is a d equal to 0 case. Okay, now let us see. So finally, what is all cases here? So we discussed three important cases. The first one is f of alpha into f of beta is greater than 0. F of alpha into f of beta greater than 0 means what is condition? Only one root must be real and remaining two are imaginary. Next, second one, if f of alpha into f of beta is less than 0, f of beta into f of alpha into f of beta is less than 0 means the three roots are real and different or distinct, or f of alpha into f of beta equal to 0. F of alpha into f of beta equal to 0 means three roots are real and equal. Okay, these are three important conditions. These three are most important condition in advanced level. Okay, now I will explain one problem on this concept. Let us see. The example is, so find the all possible value of the function x cube minus 3x plus a equal to 0. The given function is x cube minus 3x plus a equal to 0. Find the all possible values of a such that the given function contains three real and distinct roots. Three real and different roots. So what is condition for three real and distant roots? F of alpha into f of beta is less than 0. Okay, we know that f of alpha into f of beta is less than 0. Here, what is alpha and beta? So here alpha and beta are roots of f dash of x. That means roots of quadratic. So in any problem, so first we have to calculate derivative of the given function. Later we can apply the conditions. Okay, it depends on a question. Here, what is f dash of x here? F dash of x is equal to 3x square minus 3 and equivalent to 0. Then 3x square equal to 3. Then x equal to plus or minus 1. That means alpha is equal to 1 and beta equal to minus 1. Now apply this condition. F of alpha into f of beta is a less than 0 condition. So what is f of alpha? So replace x by 1 here. That means 1 minus 3 plus a into next replace x by minus 1. Next case, that is minus 1 plus 3 plus a, which is less than 0. That means this value is a minus 2 into, and this is a plus 2 is less than 0. A minus 2 into a plus 2 is less than 0 means, so what is the range of a here? It lies between minus 2 to plus 2. The possible values of a is, or the range of a is lies between minus 2 to plus 2, or it can be written as a belongs to open interval minus 2 to plus 2. Okay, this is the example on this concept. So in your advanced level examination, they will ask this type of questions either in passage type or single answer type. Okay, so this is the advanced level concept of the cubic degree polynomial. That means nature of the cubic degree polynomial. Okay, thank you very much.